In the Beginning by Walt Brown. Page 122, this is the Mid-Oceanic Ridge. I'm reading from the 8th edition. It's a little easier than reading vertically. World Ocean Floor by Marie Tharp. Notice the characteristic margins of each continent. Seaward from each ocean beach is a shallow, gradually sloping continental shelf, then a relatively steep drop called the continental slope. This strange pattern is worldwide. Why? For a better look at the typical shape of this margin, see figures, let's see, it'll be different in the 9th edition. Also notice the different characteristics of 1, continents and ocean basins, and 2, the Atlantic and Pacific basins. 90 East Ridge is 90 East Ridge is so named because it lies almost exclusively along the 90th degree east longitude. It is straight, 3,000 mile length, and curious north-south orientation aimed at the Himalayas are important clues as to past events on Earth. So he's talking about 90 East Ridge right up here. Yeah, 90 East Ridge right here, pointed directly at the Himalayas. Okay, as one moves toward polar regions, this type of map projection, east-west distances are stretched and do not reflect true distances. Okay. Why does the Mid-Oceanic Ridge intersect itself in the Indian Ocean, shown by the black circle? The plate tectonics theory says the seafloor is spreading along the Mid-Oceanic Ridge, so at the intersection point, spreading should be occurring in 4 directions on both sides of 2 ridge axes. Is a deep hole opening up at that point? Obviously not. As will be explained with many more examples in this and in the next chapter, seafloor spreading is a myth that alone falsifies plate tectonics. The hydroplate theory provides a simple explanation for that intersection point and the Mid-Oceanic Ridge. Okay, now we're going to do the ocean map. Unlevel sea level. An amazing technological development reveals details on ocean floors. In 1983, the U.S. Navy's CSAT satellite measured with a radar altimeter the satellite's distance above the ocean surface with an accuracy of several inches. Sea level is far from level. Instead, the ocean surface humps up over mountains on the ocean floor and is depressed over trenches. The gravitational attraction of the Hawaiian Islands, for example, pulls the surrounding water toward them, raising sea level there about 80 feet higher than it would be otherwise. The satellite's data have been color-coded to make the spectacular picture of the ocean surface. Darker areas show depressions in sea level. Notice that the ocean surface is depressed over long scars called fracture zones, running generally perpendicular to the Mid-Oceanic Ridge. Which theory explains this? The plate tectonics theory or the hydroplate theory? Also consider the nearly intersecting fracture zones in the South Pacific. Which theory explains them? Let's zoom in on the Hawaiian Islands. Yeah, where are they? There's Africa, here's America. Ooh, look at that. There the Hawaiian Islands are, 80 feet higher, and there it's lower above the trenches. Very interesting. The technique for showing features on the ocean floor has steadily improved since 1983. Today, ridges and fracture zones can be seen in places that are inconsistent with the plate tectonics interpretation. For example, a crooked fracture zone can be traced from South America to Africa, and oceanic ridges are found in the Gulf of Mexico. As you will see, both are consistent with the hydroplate theory. Okay, a crooked fracture zone from South America to Africa. Crooked fracture zone. Okay.